All right. So reflection means bouncing off, and obviously light can reflect off of surfaces depending on their color and texture and so forth. And when we talk about reflection, the parts of a reflection include the incoming light ray that's coming into the surface. That's called the incident ray. Think about incident incoming. We can then, draw a perpendicular line, and you don't have this, so draw it in. A line perpendicular to the surface, right where the incoming ray meets the surface. We draw a perpendicular line. That is called the normal. And then we have the reflected ray, the ray of light that bounces off of the surface. That reflected ray comes off. And the law of reflection tells us that the angle of incidence, the incoming angle, is equal to the angle of reflection. So these angles are the same.
Why do they have to be the same?
That's just the way physics works. That's just what happens. And so if we look at here an animation, we have the incoming ray, we have the reflected ray, and again, it's always at the equal angles. Make sense?
Were you moving at the speed of light today?
What's that?
Were you moving at the speed of light?
Yeah.
Mr. Ross?
Yes.
I have a question.
Yes.
Is the normal just called normal or the normal?
It's the normal.
Or is it like the normal line?
It's the normal.
Like, that doesn't make sense though.
What doesn't make sense?
Like the normal, that's like confusing. It's like
It's an imaginary line.
It's like
So the normal is just an imaginary line
Please connect.
that you can use to judge those angles.
Yeah, but what's normal though?
It doesn't. That's just what it's called. All right. So if we look at some examples. Number one.
Grass.
So draw in the normal. Draw the normal for this ray. Draw the reflected ray as well.
Do you have to label?
Sure.
No.
You could abbreviate IR for incident ray, RR for reflected ray, N for normal, AOI and AOR.
What's that?
Angle of incidence, angle of reflection.
Wait, what is it? A N?
So the normal, now in this case, the normal is horizontal because the surface it's reflecting off of is vertical. So you have the angle of incidence, you have the reflected ray.
Wait, which one's the angle of incidence though?
The angle between the incident ray, the incoming ray, and the normal is the angle of incidence. The angle between the normal and the reflected ray is the angle of reflection. Number two. Again, draw the normal, draw the reflected ray. I know this is not complicated, but
Mr. Ross.
yes.
Why are there textures for?
I don't know, why not?
Why not?
So we have the
Wait, that's on you.
rays there.
I don't like drawing or writing.
I don't like labels.
And then the third one should look like that.
Sorry, my ears are ringing.
Am I in touch?
Everyone's is.
Mine aren't.
Mine are.
Oh.
All right, we can also, so we got that. Now we have a couple different types of reflections that we talk about. Okay, a regular reflection is a reflection off of a flat surface, and so each incoming light ray has its own normal, and its own reflected ray, and its own angle.
Oh, my phone is
So light hits those surfaces, and all of those incident rays that are parallel, after they're reflected, they're also parallel.
Do we have to draw in all those?
Sure, draw them
I didn't do so well.
in. You just know the basic idea.
Ross.
Why do you do this too?
we call irregular reflection. When you look in a mirror, for example, just a mirror like in your bathroom, it's giving you a regular reflection. It's a flat surface, okay? And the light rays that are coming in parallel, they reflect parallel as well. And so it's also why, you know, the angle that you look at into a mirror determines what you see on the opposite side. Okay, as you move to the side, you could see a wider, those wider angles. But other times you have a rough surface. And this is called a diffuse reflection. Now, what do you think? So all of these incoming rays are parallel. Once these rays are reflected, will they still be parallel?
Nada.
No, because you need to look at where each incident ray hits the surface it's reflecting off of. If we look here at this first ray, again, we need to draw our normal perpendicular to the surface where the incident ray hits it. So this normal is pointed this way. This normal is going up and down, basically. This one's similar. This one's tilted a little bit. It's because of this rough surface, this curved surface, our normals are not all parallel to each other anymore. So which way is this light ray gonna reflect? That way.
Okay.
And this one will reflect this way, and so forth. But they're all now reflecting at slightly different angles, giving not a clear reflection. It's going to be a distorted reflection.
So that's what happens when you're looking into like pool of water and then there's like.
Yes, or if you look at one of those funhouse mirrors that are curved. Some parts of you, they look stretched out. Other parts look condensed because of that curved surface and because of the way the light rays intersect it. Yes.
Have you ever looked into a funhouse mirror and seen yourself normally when everyone else sees themselves differently?
All right.
I don't get it.
Sorted in real life.
Now, we also have a couple types of mirrors that can be used to change light in predictable ways. So, convex mirrors. Convex means curved out. Okay? Convex mirror. If you think about it, as this incoming light ray comes into this curved surface, which way is the normal going to go? Give me compass directions. It's going to be northwest. This one, again, it's perpendicular to where it's hitting the surface. This one's going to be southwest. So when this light ray enters, which way is it going to reflect?
North.
Northish.
Wait, I'm confused like how you found where the perpendicular and the
Yeah, so-
Where to put the normal?
yeah.
Perpendicular.
It's not even
And-
perpendicular.
It's
Yeah.
perpendicular because the surface is curved here. It's curved down, so perpendicular is here.
I suppose.
Can we spend the last 15 minutes?
Oh man, I think I get it now.
So these light rays are going to reflect back out, but they're going to be diverging.
Mr. Duras, but not the bully.
I'm not a bully.
I
He's saying I'm lazy.
So convex mirror
What?
causes the reflected rays to diverge.
Oh, so those triangles should be the same?
So if you are an example of a convex mirror, if you look in the back of a spoon, you could sort of see a wide area behind you. Or one of those like anti-shoplifting mirrors. Like if you see at a store, it's up in the corner, and it's so that the cashier can look at it and see a wide area of their store to be sure people aren't stealing anything from them. Sometimes you might have a bike mirror attached to your bike that's going to be convex so that you could see a wider view and be sure there's no cars coming. Those are convex mirrors. They give you a wider field of vision, but usually the image that you see is smaller than the object actually is.
Contacts?
And the image is erect or upright. Okay? And it's reversed from side to side as well. door security mirror, a rear view mirror in a car, those are examples of convex mirrors. And I'll show you some actual examples of these mirrors in a few minutes. A concave mirror is working in basically the opposite direction. Okay. So, let's think about this. When this incoming light ray hits the surface here, where would I draw the normal? Now I'm not going to draw it straight back out because the surface is curved. It's curving this way. Nicholas?
You would draw it like
Yes. Draw it in towards the middle. That's, if you look right where this light ray intersects the surface, that's perpendicular right at that point. Right there. This is perpendicular. Same thing down here. If I draw a perpendicular line, it's going to be facing in.
This is so hard.
It's not that hard.
That's confusing.
And again, what are the light rays going to do?
Bounce.
Oh, I did it go bounce
They're
in.
going to bounce in. They're going to converge.
This girl, I don't understand that.
They bounce and they converge. Now, this type of mirror, because the light rays converge and then cross each other, when you're up close to the mirror, it's going to magnify the image. And it's going to be upright. But if you step back behind the focal point of the mirror, if you ever looked at the inside of a spoon, up close, you're kind of magnified. What if you hold it far away?
You're upside down.
You're upside down. Okay? Once you go beyond that focal point of the mirror and go back here, then the image appears smaller and it's inverted or upside down. If you have like a makeup mirror or something that magnifies the image a lot, you look up close and your face is really big, but if you step away from the mirror a little ways, you'll see the image flips and it's upside down. Okay?
Or image, like I'm pretty sure it needs to be spot on or
No, it's just as long as you have the idea.
Okay.
Okay? This is called the focal point, where those light rays converge.
Is that where you're magnified?
Yes, when you're closer than that point, you're magnified. Beyond that point, you're made smaller and
I'm
flipped
nervous
upside
because
down.
I'm not drawing this
It's
drawing.
okay, as long as you have the general idea.
I don't think I even have a channel.
When you're close, it doesn't. It's upright.
I know, but if you were like.
Because think about it this way. All right, if you want to, this is beyond what you need to know, but if you think about it logically, it should make sense. If you're here, actually, let me see if
That
I
kind of looks like an eye.
yeah, I can do this. All right. Now, my question's kind of annoying. All right, if you are standing here, this is you. I don't want to mess up my question.
Whoa.
All right.
I can't see it.
So, if you're standing here, as you look in the mirror, if you trace this back, that's how big you're going to look. Okay? That's the image you seem to see. If you go back here, okay, think about it this way. This light ray from you, okay, is traveling, where am I here? Okay, so this light ray is traveling in. That's a light ray from your feet, right? When it reflects, where's it going? So here it's still there, but once you're here, where did it go?
Your face.
Up top. So this light from your feet travels here. When it reflects up here, beyond that focal point, then your feet are up in the air.
Oh, that's so
This light
smart.
ray from your head reflects, and once you go beyond here, that's your head down there.
Oh, that's so cool.
That's weird.
So that's why you appear to flip.
I don't get the perpendicular
Okay.
thing.
So will you like automatically just go like boom?
Yeah, as soon as you step beyond that point, your image flips. So perpendicular, look. If you think this surface,
I can't see my head.
this surface is curved, correct?
Correct.
So if I look where this ray hits that surface, how do I draw a line perpendicular there? Would this be perpendicular? No, because this surface, what perpendicular, if I draw sort of a line straight where it meets, perpendicular is this way.
Well, that makes it more.
Okay? And so that's why that line is perpendicular, is converging. And if you look back here, same thing. You can see why the other type of mirror never flips you upside down. Okay?
Oh.
Is there a focal point
No.
of a convex mirror? No, the light rays come in, they never cross. Okay? And so therefore, you don't flip in that type of mirror. All right.
This is so confusing.
All right, let's finish up today by talking to you about color. And we talked about this already. Color of an object that you see is determined by whatever colors it reflects. White light is made up of which colors?
Oh.
All of the visible color. All of the Roy G. Biv. Red, orange, yellow, blue, indigo, and violet.
Roy G. Biv.
Yep.
Happy birthday!
No. Mr. Carey?
Tell him I say happy birthday.
Mr. Carey, do you have those mirrors? Mirrors? All right. So,
Oh, why is there big? What's
an object, blue, indigo, and violet are the names of those colors. So, some objects reflect all light. Those objects will be what color? White. Some objects absorb all light. Those objects are black. Or other objects absorb some colors and reflect others. And those appear whatever color light they reflect. So,
Are we done?
no.
It's a pizza.
All right. So, if we look, if this light is hitting this white object, okay, the reflected rays are all the colors are reflected. That is white light. This one, if the object is red, white light comes in, but all colors are absorbed except for red, and the object appears red. How about black objects?
Nothing.
They absorb all light, and therefore they appear to have no color. And the same thing, blue.
Whoa, whoa.
Yes, all you have to do is draw
Let me see something. All right. Yeah, well, let's do it. All right, two types. We already talked about this. A regular reflection, like on a flat mirror in your bathroom, shows an image that's almost exactly like the original, except, okay, it's flipped right to left. The object in the mirror, if you're standing 2 feet away from the mirror, where does it look like you are in the mirror? 2 feet on the other side of the mirror. Yes. And the image is upright. A regular reflection provides an upright image. You're not flipped upside down. A diffuse reflection, light is scattered in different directions, caused by a rough or uneven surface.
Mr. Juros, why I will think I can't take care of the mirror. It's a trick. Okay.
All right. What type of mirror am I holding?
Convex.